BCA charts, and limiting reactants. If 92.3 grams of nitrogen reacts with 64.9 grams of hydrogen, how much ammonia will form? Now, if nobody's seen this reaction before, this is a super important reaction, arguably one of the most important reactions in the world. This is called the Haber process. And this reaction is the reason why there's so many people on the face of this planet today. If they had not perfected Le Chatelier's principle and this chemical reaction to produce nitrogen, the carrying capacity of the Earth would be 3 billion people. You guys know, anybody know how many people are actually on this Earth now? Yeah, a lot, right? It should blow you away. Since I was your age, the population on Earth has doubled. And the reason is because when you grow crops, it depletes the nitrogen in the soil. So long time ago, they used to have to rotate crops and leave fields barren and not planted on for years while the nitrogen rebuilt. It was only when we had the ability to what's called fix nitrogen with this chemical reaction were we able to create fertilizer. So fertilizer is arguably one of the most important substances in the world. Interesting side note, Fritz Haber did all of his work and perfected this when just before, and obviously you could tell from his name that he was German. So unfortunately, when the World War started, he got into bomb making, because this is not just about making fertilizer. It's also about fixing nitrogen, which can be used in bombs. If has anybody ever heard of the Oklahoma City bombing? There's a Netflix special on it if you're into those kind of documentaries. That's super interesting. And that's Timothy McVeigh, who was a moron, just loaded a truck full of fertilizer and turned it into a bomb and parked it in front of the city hall in Oklahoma City. Unfortunately, he parked it right underneath a daycare center. So hundreds of people died, and unfortunately, quite a few of them were babies. But that's an interesting story. It's on Netflix if you have any interest in that kind of stuff. So first, let's do the balanced chemical reaction. So we're going to do nitrogen plus hydrogen forms ammonia, NH3. It's NH3 because nitrogen has 5 valence electrons and room for 3 more. So he will share with the electrons with 3 hydrogens and always forms NH3. This is called ammonia. NH3 goes by its common name, ammonia, just like H2O goes by its common name, water. So now, in order to do this correctly, we have to balance. So I'm going to make the odd number of hydrogens even by putting a 2, 3, and then we're balanced. So my mole ratio is 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. And I'm going to do BCA chart. I know this is a limiting reactants problem because I have 2 givens of 2 different reactants. Let's remind ourselves. B is before. C is change. And A is after. Now, let's put our givens in here. Remember, our givens in the BCA charts always need to be in moles. To change grams to moles, we divide. So in my calculator, I'm going to type in 92.3, and I'm going to divide it by the molar mass of nitrogen, which is not N at 14.01, it's N2. So it would be 28.02. So the number of moles of nitrogen is 3.294. I'm going to do the same thing with hydrogen. 64.9 divided by the molar mass of H2, which is 2.016. 2 times that of hydrogen. And I get 32.19 moles. I made the problem this way so that you guys could see. Don't automatically pick this smallest quantity and decide that that's what the limiting reactant is. We can see that we need 3 times as much hydrogen. Well, 3 times as much hydrogen, I mean, I need 3 times the amount of nitrogen. So 3 times the amount of nitrogen would be 3 times 3.294, which is going to be right around, not exactly, right around 10. I have 10 and then some. I have more than enough hydrogen. So as soon as I say I have more than enough hydrogen, I know that nitrogen is the limiting reactant. So let's label these. So once I decide that nitrogen is the limiting reactant, I know that this gets a 0. But let's do this step by step. Right here is going to be the starting quantity of the products, which is always 0. The starting quantity of the products before a chemical reaction happens is always 0. That's why the reactants get a minus and the products get a plus. So let's label that. That's because reactants are turned into products. So the amount of the reactants decreases, the amount of products increases. Then we use the balanced chemical equation with X. So the coefficients from the balanced chemical equation with an X. So let's just label that. Okay, so now we see the limiting reactant always gives us the problem to solve for X. So my problem becomes 3.294 minus X equals 0. So X is equal to 3.294 moles. Remember, in the BCA chart is always moles. So now we can replace the after quantities with actual numbers. So for hydrogen, let's do hydrogen next. 32.19 minus 3x equals the after for hydrogen. So 32.19 minus 3 times x, which we just solved for, equals, so in my calculator, 32.19 minus 3 times 3.294. And afterwards, I will have 22.308 moles of hydrogen left over. NH3 is 0 plus 2x. So the after for NH3 is 0 plus 2 times 3.294. So let's label these more carefully so everybody can tell. This is the after for hydrogen. This is the after for NH3. So in my calculator, 2 times 3.294 is equal to 6.588 moles. That's how much ammonia we produce. Now, if they asked us to change that to grams, remember to go from moles to grams, we multiply. So 22.308 moles of hydrogen in 1 mole of hydrogen. I put moles of hydrogen in the bottom to cancel. There's 2.016 grams of hydrogen. So in my calculator, that's why I am going to multiply and get 44.973 grams. My given had 3 sig figs, so my answer becomes 45.0 grams of hydrogen is left over. And now let's do the same thing for ammonia. One mole of NH3 is 17.034 grams. So 6.588 times 17.034. My calculator tells me 112.220. I'll round that to 3 sig figs. 112 grams of ammonia was produced. So we started off, we put nitrogen and hydrogen in a reaction vessel. The reaction started and we produced ammonia, which is NH3, up until the point where we ran out of nitrogen. Once we run out of nitrogen, the reaction stops and the rest of the hydrogen remains unreacted. When the reaction's over, we will have no nitrogen left over, and we will have 45.0 grams of hydrogen, and we will have produced 112 grams of ammonia.